Hello everyone. Class 12th topic is solubility of haloalkanes in water and second topic will be stability of haloalkanes. First let's understand solubility of haloalkanes in water. Rx means haloalkanes are partially or almost insoluble in water. Our haloalkanes are partially or almost insoluble in water. Let's find out the reason for that. First, we need to understand when two liquid mix in each other, what happens over there. Suppose this is liquid A, in which all the particles are AA. So obviously between A and A, some force of attraction will be there. And this is liquid B, in which all particles will have force of attraction between BB. Now let's mix them. On mixing, they will dissolve in each other only when new interactions like AA particles and BB particles are going to dissolve in each other. So obviously new force of attractions will set up between A and B. And when new attractions will set up between A and B, energy will release out. Now, if this energy is able to break old force of attractions, then liquid A will dissolve in liquid B. This was liquid A, in which all particles are of AA, and obviously between AA we have a intermolecular force of attractions. And here we have liquid B, in which BB particles have this intermolecular force of attraction. Suppose we want to mix them. When AA particles and BB particles will make interaction with each other, energy will release out. If this energy is sufficient to break old force of attractions, old means the force of attraction between AA and BB. Obviously, A and B will mix together only when their old force of attractions will break. And to break those force of attraction, we require energy. From where energy will generate? Energy will generate from these new force of attraction, new interactions. If this energy is able to break old force of attraction only, A, B, A, B. Such type of new interactions will generate and A and B will dissolve in each other. And if this energy is not able to break old force of attractions, so A liquid will not mix in B, or you can say B liquid will not mix in A. They will remain in this condition. Like this. AA particles will not get separated from each other. BB particles will not get separated from each other, and they will make different layers. like this. The heavier liquid will make a different layer in the bottom of beaker, and lighter liquid will make different layer here. So the layers will be separated like oil in water. The two liquids are not getting mixed in each other because these new interactions are releasing little bit amount of energy, and those energies are not enough to break old force of attractions. Same reason is there in the case of haloalkane in water. Haloalkane particles, which we generally representing with Rx, and water molecules H2O. Now we know if we have liquid water, so H2O will have some force of attraction with each other, which we called old force of attraction, and we know it is hydrogen bonding, H bond. Similarly, if I talk about Rx, haloalkane liquid, so RX particles will also have a force of attraction, X negative, R positive, dipole-dipole interaction, DD interaction. Now when we mix them, new interactions will set up, means H2O particle will start making interaction with Rx particle, its positive particle, and this side from negative. A new interactions will set up. These new interactions will release out energy. But this energy is not sufficient to break their old force of attractions. And if old force of attractions will not break, how a new attractions can set up properly? Means H2O molecules cannot be mixed in Rx, or Rx molecules cannot be mixed in H2O. This is the reason that why haloalkanes are insoluble or partially soluble in water. That's it. This is the reason for solubility of haloalkane in water. Second is stability. If I talk about stability of haloalkane, means Rx, where R is representing alkane part, X is representing halogen, we know they are of four type: RF, RCl, RBr, and RI. Fluoroalkane, chloroalkane, bromoalkane, iodoalkane. Now easily we can answer about their stability. The stability order is this: RF is most stable, then RCl, then RBr, and RI is least stable. So when you place RI in sunlight, the bond between RI break and it create RR and I2, means alkane and iodine will get separated. That's why in start it was colorless, but due to this dissociation, the color of iodine develop over here, that is violet or brown. So colorless Ri becomes violet or brown due to generation of iodine. Now why this is happening? This is happening because of these bond lengths. Between R and F, the bond is very short because of very small size of fluorine. Short covalent bonds are strong covalent bonds, and as we proceed toward iodine, the covalent bond length will increase because of increased atomic sizes of halogens. Out of all halogens, iodine have biggest size. That's why the bond length between R and I is biggest. That's why this bond is weakest. So when you keep your iodoalkane under light, after some time you will watch colorless iodoalkane is getting violet or brown color. It is due to generation of iodine there. And if we talk about stability order, RF is most stable, then stability will decrease. This is the decreasing order which I have written here. And Ri will be least stable. So that's it. This is the end of the topic, solubility of haloalkanes in water and stability of haloalkanes. Reasons we have discussed. Thank you very much.